is really just an extension of what we've been doing throughout the course. Just we're going to be dealing with trigonometric transformations. And you've done this before in grade 11. The only thing you did it with is in degrees instead of radians. So we are going to be transforming the sine curve and the cosine curve. So it's very important that you remember those critical points for sine and cosine. The sine starts at 0, 0, goes up to pi over 2 and 1, down to pi and 0, 3 pi over 2 and negative 1, and 2 pi and 0. And you join those up for the primary graph of the sine curve.
Interruption. When all grade 11 classes
The cosine curve starts at 0 and 1.
Classes, please report to the auditorium now for the Remembrance Day Assembly. Mr. Roddy, Mr. Trig, Ms. Hager, Mr. Bonato, Mr. Kuehl, Mr. French, Ms. Hodgson, Ms. Smith, and Mr. Timothy, and all grade 11 classes to the odd now.
Okay, so we're going to be transforming the primary graphs. So the red graph is the cosine curve, the green graph is the sine curve. We're going to be putting them through transformations and then finding the new amplitude, the new period, the phase shift, and the vertical translation. So remember that the amplitude is a distance. It's the distance between the highest point and the lowest point divided by 2. So the amplitude of the untransformed sine and cosine curve is 1. We learned the other day that the period of the sine curve and the cosine curve, both of them is 2 pi. The phase shift is the units that are moved to the left and to the right. Okay. Since this guy is not transformed, we don't have a phase shift, so it's 0. And then the last thing that we'll put it through is a vertical translation. And again, this is the primary curve, so there's no vertical translation. So what we're going to be doing is putting these functions through transformations. So we're going to be adding parameters to the sine curve and the cosine curve. So in general, the transformation of the sine curve again, this is exactly what we did with transformations in Unit 1, 2, and 8, 9, we did log transformations. The A, B, C, and D values, they all transform the function, put them through reflections, compressions, reflections, move things to the left, move things to the right, move things up, and move things down. So we are just going to be transforming the sine curve and the cosine curve. Okay. But once we put the sine curve and the cosine curve through transformation, that's going to change all of these guys, the amplitude, the period, the phase shift, and the vertical translation. So in general, I'm going to use A and P to represent the amplitude. The amplitude is the absolute value of the A value. Okay? That's the most common mistake people make. Is they write down the amplitude as a negative. It can never be a negative, it's a distance. Okay? So the amplitude is the absolute value of the A value. The new period, after it's been put through a transformation, is 2 pi divided by the C value. The phase shift is D units to the right or to the left, depending on whether D is positive or negative. And the vertical translation is B units up and down, depending on B if it's positive or negative. Okay, so just a couple quick questions on identifying the amplitude, period, phase shift, and vertical translation through transformed functions. So example, state the amplitude, period, phase shift, and vertical translation of the function Okay, so the negative 1/2, 3 pi over, that should be an x, not a pi. Pi over 6 and negative 2, I'll do something to the function, right? The amplitude can be found by taking the absolute value of the a value. The a value in this case is negative 1/2. So the amplitude is 1/2. And most common mistake people make, again, the amplitude can never be negative. It's always a positive value. The period for the sine and the cosine transformation is always found by taking 2 pi and dividing it by the c value. The c value in our transformation is 3, so the period of this transformation is 2 pi over 3. That means it'll only take 2 pi over 3 units for it to complete its primary cycle. The phase shift is your d value, and your d value here is negative pi over 6, or you can say pi over 6 units to the left. Okay. And the vertical translation is negative 2 units or 2 units left. Any questions on that? Okay. Y is equal to 3, the cosine of 1/3 x plus pi over 4 will be minus pi over 4 plus 3. Okay, so in order to identify the A, B, C, and D values to help you figure out the amplitude, period, phase shift, and vertical translation, the C value always has to be factored out. Okay, so the transformation always has to be in this double bracket notation. If it's not, that's your first step, is to put it into the double bracket notation by factoring out your C value. So this becomes 3 times the cosine of, and I want to factor out 1/3 out of the x, which is pretty easy to do. 1/3 out of the pi over 4 may be a little bit more difficult. So if you're unsure how to do that, a method that'll always work is take the pi over 4 and divide it by what you're factoring by. Invert and multiply. So if you take out a factor of 1/3 out of pi over 4, you'll end up with 3 pi over 4. You just take a second to make sure that when you multiply it back in, you get what you had in the line above. 1/3 x is 1/3 x. 1/3 times 3 pi over 4. The 3's would divide through, leaving me with pi over 4. Just takes a second to make sure you've got it correctly. Again, very common mistake. One, people forget to factor it out altogether. Okay, 110% you're going to get a question like this in the test. Second is they don't factor it out correctly. Just take a second to make sure that multiplies it back in. Because once you have all that, then the rest of it is taking the absolute value of the A value. The period is 2 pi divided by the C value. In our case, the C value is 1/3. So 2 pi divided by 1/3, invert and multiply. So the period of this function is 6 pi. Now it takes 6 pi to complete its primary cycle. The phase shift is positive pi over 3. Excuse me, 3 pi over 4 units, or you can say positive or to the right, whichever way. And the vertical translation is this guy's moving up 3, so positive 3 units, or you can say 3 units upwards. Any questions on identifying the amplitude, period, phase shift, and vertical translation from a given transform function? Pretty straightforward stuff. And again, I'm moving kind of quickly, so I want to fit this in before the others. Any questions? Okay, so what we're going to do now is we're going to take these transformed functions and graph them. So in order to graph them, we are going to use a transformation mapping. This works for any single function in the world. It doesn't have to be a trig function. It could be a log function, exponential. It could be anything. If you take any function and put it through a mapping where you're putting parameters in front of the function and inside of the function, then every point on the original function goes through a transformation and ends up being a new point. And you can figure out that new point by taking 1 and dividing it by the c value, multiplying it by x, and then adding on your d value. That'll give you your new x coordinate. And the new y value can be found by taking a, multiplying it by that new, by the y value, and adding on b. So this little formula is going to be very important to us in this unit. It's called the general mapping. We are going to use the general mapping to take the 5 critical points of sine or the 5 critical points of cosine, put them through the general mapping, see where they end up, and then we're going to graph them. Okay? So if you're following along with me and want to try this, you might want to take out that piece of graph paper I gave you the other day. And also, if you're not great with fractions, you might want to take out your calculator. So you will be responsible for doing questions exactly like this on your test. Right? So we want to graph the function y is equal to 3 times the sine of x, bracket 2x minus pi over 4 minus 1, and we want to graph it from negative 2 pi all the way up to 2 pi. Okay, so the first thing I want to do is I want to write down the general mapping. So the general mapping is each critical point of sine is going to become a new point, 1 over c, so 2 is my c value, right? So this is my a value, my c value, my d value, and my v value. So 1 over c is 1/2 times x added to my d value, which is pi over 4. My a value is 3, multiply that by y, and subtract off my b value. Okay, so see some of you struggling to see that. So now what I'm going to do is I'm going to take each critical point of sine, because it's the sine function, and I'm going to put it through this transformation. So the first critical point of sine, that's why it's very important to remember them, is 0 and 0. What I'm going to do is I'm going to substitute 0 in for x. So 0 times 1/2 is 0, added to pi over 4 is pi over 4. I'm going to substitute 0 in for y. 0 times 3 is 0, minus 1 is negative 1. So the point 0, 0 on the original sine curve, once it went through this transformation, ends up being the point pi over 4 and negative 1. Make sense? Now I want to figure out where the other points end up. So I'm going to do this for pi over 2 and 0, pi and negative 1. Oops. It should have been 1. Okay, that's right. 1, 0, 3 pi over 2 and negative 1, and then finally 2 pi and 0. So this is where, especially when you get into the harder fractions, this is where your calculator can help you out to save some time. Okay? The only thing with when you're putting these into the calculator, it won't accept the pi values because it'll change it to a decimal. So just forget about the pi's if you're plugging this in. And just plug in the fraction instead of pi over 2, just plug in 1/2. Take 1/2, times it by 1/2, and then add on 1/4 and get that answer, and then just put the pi back in at the top. So what is 1/2 times 1/2 added to 1/4? And if you don't know how your fraction calculator works, and again, I've offered this many times, if you want help, come up and see me. So what does that work out to be? Yep. Perfect. And now we throw the pi back in, right? Okay, so Rebecca said it works out to be 2/4, which is perfect, but then you always have to simplify it, right? So 2 pi over 4 simplifies down to pi over 2. Substituting 1 in there, 1 times 3 is 3, subtract 1 is 2. So that point became the point pi over 2 and 2. Now we do it with pi. Substitute pi in. Again, if you're doing this on your calculator, don't use the pi's and just put the pi's into your final answer. So you go 1 times 1/2 is 1/2. 1/2 plus 1/4 would give you 3 over 4, and then throw your pi back in. So the point pi and 0 ended up becoming the point 3 pi over 4 and negative 4. Every single time the sine or the cosine curve, they're always going, the x values are always going to go up by the same amount, okay? And then the y values are going to oscillate between the highest value, the middle value, and then the lowest value. So the sine curve is going up here for the domain by pi over 2. Anybody figure out what it's going up by here? So go from pi over 4 to pi over 2 to 3 pi over 4. What am I going up by? Now remember, when Rebecca first told me this, she told me it was 2 pi over 4. So pi over 4, 2 pi over 4, 3 pi over 4. What seems to be the pattern? Right?
It's increasing by pi over 2.
Right, so what would the next one be? Right, because the next one will be 4 pi over 4, which is pi. So if you figure out the pattern, then you can save yourself a little bit of time as well. If you have no idea what I'm talking about with the pattern, ask me, I'd like to explain it to you. But if all else fails, you can just take this value, substitute it in here, multiply it by 1/2, add it to that, and you'll get that answer anyway. Okay? Substituting -1 in, I'll get negative. You can substitute 2 pi in, or you can realize that the next number, this is 1 over 4, 2 over 4, 3 over 4, 4 over 4. The next one's going to be 5 over 4. And then 0, negative. Ah,
At what point is it for the pattern? How many do we have to do?
after the first one, if you can figure it out. It's always going to go up by the same amount. Okay? Keeping in mind, you'd have to get this one right. You can screw it up. So these 5 points are my new critical points for sine. So I'm going to graph them now. And this is where you're going to use your graph paper to help you. Okay? So this is a very important part. You want these 5 points to fit onto your graph. So you're always going to go up by the greatest denominator or the smallest fraction. So look for the biggest number that's on the bottom. The biggest number on the bottom is a 4. So you're going to go up by 1/4. Okay, so when you're labeling, you're going up by 1/4. 1/4, 2/4, 3/4, 4/4, which is pi. So this would be 1/4, 2/4, 4 over 4, 5 over 4, 6 over 4, and 8 over 4. And that's the part that I think people struggle with, is the fraction part and simplify. And then the other side, one, 2, 3, 4, -1, -2, -3, -4. So when you're labeling, do not label your graph until you figure out your transform points. go up by the smallest fraction or the biggest common denominator, the biggest denominator on the bottom, because it'll always work out for you. So now you want to plot the point 1 pi over 4 and -1. So here's pi over 4, here's -1. Put it down. The next one is 2 pi over 4, or pi over 2 and 2. So pi over 2 and 2. Three pi over 4 and -1. 3 pi over 4 and -1. Pi and -4. Here's pi, -4 is down here. And then really right now, I don't even need to look at any more points, because now I'm just going to use the pattern of the graph, because I have the high point, I have the low point, I know where the middle points are. So to get to the next points, I'm just going to use the actual graph paper. I went over 1, up 6. I went over 1, down 6. Went over 1, down 6. So to get to the next point, I'd go over 1 and up 6. And I would go over 1 and up 6. Over 1 and down 6. Over 1 and down 6. And I keep doing that until I reach the end of my graph. Does that make sense? So that's why I gave you that piece of graph paper, because you will have nice graph paper on your test. So it's important to identify the pattern, and you're just going to identify the pattern on the other side as well. Okay? So here I was at the middle, so I go over 1, down 6, over 1, up 6, over 1, up 6, over 1, down 6, over 1. And I just continue this on until I reach the end of where I want to graph it to, which is right here, because it asks me to graph it between -2 pi and 2 pi. So I just continue on with my little pattern. Once I've done that, using your pencil, not a ruler, you just join it up as best you can in a smooth curve. And that's the transformed function. Sine y equals 3 sine 2 x minus pi over 4 minus. Okay. So now let's try it with a cosine curve, and then again throw in a different wrinkle. I didn't want to do that. Let's do this. Okay, so let's try it with this one. Y is equal to -1/2 the cosine of 1/2 x plus pi over 3 plus 2. And we are going to graph this one from -3 pi all the way to +3 pi. So before I can do my general mapping, I have to make sure that this is in the proper form in order to state it. Is it in the 2 bracket form? No, so I have to put it into that form. Okay. Again, this is by far the most common mistake people make. The amplitude is a negative and forgetting to factor out the C value. Okay, so the first thing you want to do is make sure it's in that double bracket form by factoring out that C value. If you factor 1/2 out of pi over 3, again, if you forget how to do it, just take pi over 3 divided by 1/2, and you will get 2 pi over 3. Just check it, right? So 1/2 times that, the 2's would cancel out, and I end up with pi over 3, I'm good. Plus 2. So you have your A value, your C value, your D value, and your B value, and now you're putting them into your general mapping. The general mapping is 1 over the C value, which is 1 over 1/2, but that doesn't look very nice because you want to simplify it. What does 1 divided by 1/2 simplify down to? Yep, 2. So it becomes 2 times x. Yep. But that's for the A. I'm not worried about that right now. I'm just doing the 1 over C part, right? Okay. So, because I'm doing the 1 over C, so 1 over 1/2 is 2. 2 times x. Subtract off your D value. Remember that this and this are always opposite signs. Okay, so now I'm getting ready to reflect it. My A value is negative 1/2. I multiply that by y, and I add on my D value. A less common error, but it happens, is if I ask you to transform the cosine curve, and then people use the point for the sine curve. Okay? Remember, if you're doing the cosine, use the cosine points. So the cosine points start at 0 and 1. And pi over 2 and 0. Pi and negative 1. 3 pi over 2 and 0. And then 2 pi and 1. We're going through the general transformation. Zero times 2 is 0. Subtract off negative 2 pi is negative 2 pi over 3. 1 times negative 1/2 is negative 1/2. Added to 2 is 3 over 2. Again, don't use decimals. I always use exact values. Substituting pi over 2 in, pi over 2 times 2 is pi. Pi minus 2 pi over 3 would be pi over 3. Substituting 0 in, I'll get 2. So basically, if you've done the first part correctly, what would I have to add to negative 2 pi to get to pi? Yep. Right, so if I add 3 pi to the top, the next one should be 4 pi over 3. And if you forget, just put it in here. Pi times 2 pi is 2 pi. 2 pi, subtract 2 pi over 3, so you'd make that a common denominator. That would make it 6 pi over 3, 6 minus 2 squared. Okay. Substitute negative 1 in. Negative 1 times negative 1/2 is positive 1/2. Added to 2, finding a common denominator would be 5. Add another 3 to that, to the top, it would be 7 pi over 3. We've already figured out 0. Add another 3 pi to it, and we've already figured out 1. So that shouldn't take us too much effort to continue. Go back.
That first one,
This guy right here?
you're like the 0, 0.
This guy?
So when you're putting in 1 into like y, it's like negative 1 over 2, but I'm going to change the value of 2, so it's not 3, it's 2. Because it's
So-
like 4 over 2.
Like this guy here? Yeah, so putting 1 in here would give me negative 1/2 plus 2, right? And then negative 1/2 plus 4 over 2. And then adding these guys, I get 3 over 2. That's what I get. Is that good? Okay, so now that I've got my critical points transformed, what am I going to go up by on my x-axis? Traffic. So, 5. So what am I going to go up by? From here, what, 3 pi's? Like, this would be 3 pi, 6 pi, 9 pi, 12 pi. Is that what I do? So what did I say to go up by? You look at the fractions, and you go up by the biggest denominator. What's the denominator for my x values here? 2?
3.
Right, they're all 3. So the only thing I'm going to go up by is pi over 3. Okay? So pi over 3, 2 pi over 3, 3 pi over 3, which is pi, 4 pi, 5 pi, 6 pi over 3, which is 2 pi, all the way up to 9 pi. Right, so when you're labeling the x-axis, you're looking at your transformed points, and you go up by the biggest denominator, okay, the smallest fraction. In this case, they're all over 3, so that's why I'm going up by pi over 3. And I do that in the same direction over here. So it's important to do that properly because that way all your points will fit nicely onto your graph. If you don't go up by pi over 3s, it's not going to fit nicely, and you won't be able to use that little pattern thing that I've shown you. Okay, so all these points will fit nicely on the graph, negative 2 pi over 3 and 3 over 2. Negative 2 pi over 3 and 3 over 2, which is 1.5. The next one is pi over 3 and 2. Pi over 3 and 2. Next one is 4 pi over 3 and 2.5. So 4 pi over 3 and 2.5 is right there. So I have my low point, my middle point, my high point. Now I don't even need to look at anything anymore. I can just use my pattern. Right, so I went over 3, up 1, over 3, up 1. I'm going to go over 3 and down 1. Then I'm going to go over 3 and down 1, but that point is beyond the 3 pi, so I don't need to plot that one. Even though I got it as a critical one, this point doesn't fit on my range, so I don't even need it to graph it. Then on the other side, over 3, up 1, over 3, up 1, over 3, and then I'd be out of my range, so I have enough in order to graph what I need to graph. And I join it up in a smooth curve, and that's my transform function. So 110%, you're going to get questions like these, and you'll get a mark for stating the general mapping. You'll get 2 marks for doing the mapping of the transform point, and you'll get 2 marks for graphing it, and you'll get a mark if you need to factor it out. So if you do this question and give me the graph and do it perfectly, you'll get 2 out of 6 marks. If you don't show me the other way. Okay? Any questions? Okay, so I'm going to save this.